Embedded Talk.
Hello friends, and welcome to my YouTube channel Embedded Talk. I'm back with a new video on STM32WB. In this video, we will create a iBeacon using STM32WB. Let's see the agenda first. First, we will understand BLE 5.0 or 5.1 packet format. In this video, I will not cover BLE 5.0 specification and detailed protocols. We will just talk about the packet format. I will make a separate video covering BLE 5.0 specification and detailed protocol. So don't forget to subscribe my channel and press the bell icon to get notification for the new video on BLE 5.0. Then we will talk about what are beacon and few types of beacon. Then understanding iBeacon format. Then we will create project using STM32 CubeMx and configure peripheral and BLE wireless stack. We will generate a code using any preferred ID. We will write some line of code, compile it and load it into MCU. Then we will understand the code flow, that how it works. And then we will be ready with the beacon to check on our mobile phone. So here's some prerequisite that we need. So we need softwares. We need STM32 CubeMx version 5.6.0 or above. We need STM32 Cube firmware library package for STM32WB version 1.5.0 and above. Any ID of your choice. I am taking example with STM32 Cube IDE. In hardware, we will be using P-Nucleo WB55, which is a development board from ST Microelectronics for STM32WB. And in others, we need a mobile app, which is Step BLE Profile. This is the Step BLE Profile app, which you can download from Play Store or Apple App Store. So let's first see BLE packet format. So over the air BLE packets looks like as on your screen. You have 1 byte of preamble, which is fixed with the value which is 10101010. Then you have 4 byte of access address, and this address is fixed to 0x8E89BED6 in the beginning, and after the connection this access address can be modified by the protocol. Then we have from 2 to 257 bytes of protocol data unit, which we call PDU. Then we have 3 bytes of CRC, which is for error corrections. These packets can be used for advertising and can be used for data exchange. The advertising packet called advertising PDU and data packet calls data PDU. So for this particular topic, we will more focus on about advertising PDU, not the data PDU. So if we further divide the advertising PDU, in advertising PDU, we have 2 byte of header, then we have 6 byte of advertising address, which is sometimes also called MAC address or BD address. Then we have 0 to 31 byte of advertising data, which is of our interest. So we will see how these 30 bytes are further divided to send a advertising packet. This data can have multiple packets, which we call AD structure. Each AD structure have 1 byte for defining the length of the packet, 1 byte defining the type, and then multiple bytes can be for data. For example, we can see advertising packet for advertise local name. So 2 bytes of header, then we will send 6 byte of advertising address, and 31 byte can consist the name of the device, which is a local name. So let's see what are the Bluetooth beacon. So Bluetooth beacon are a hardware transmitter a class of Bluetooth low energy device that broadcasts their identity to nearby portable electronics device. Bluetooth beacon is nothing but an advertising packet in a predefined format. So whatever format we will discuss, that consists that format. The format of the beacon depends upon the beacon protocol. So let's see what are the protocols for beacons. You can have iBeacon, which is introduced by Apple. Then you can have Alt beacon. Alt beacon is actually an open source alternative of iBeacon, which defined by Radius network. Then you have URI beacon. They send a URL which can be understood immediately by any mobile phone. Then you have an Eddystone beacon. Eddystone beacon is defined by Google and it consists of three types of beacon. It has Eddystone UID, it has Eddystone URL, and it has Eddystone TLM. UID simply sends the unique ID of a device. URL is similar to your URI beacon, which sends a URL address, and TLM is basically used for telemetry. Let's see the iBeacon packet format. So as I shown before, this is the basic Bluetooth packet format. Within this, you have an advertising PDU, which consists of 31 byte of advertising data. iBeacon is actually comes into advertising data. So this 31 bytes of advertising data can be divided into 9 byte of iBeacon prefix, 16 byte of UUID, which is a unique number, 2 bytes of major number, 2 bytes of minor number, and 1 byte of transmitting power. The 9 byte of iBeacon prefix can be further divided into 3 bytes of advertising flag, 2 bytes of advertising header, 2 bytes for company ID, 1 byte for beacon type, and 1 byte for beacon length. So as I mentioned, you have preamble, 1 byte, 4 byte of access address, PDU for header for 2 byte, PDU MAC address of 6 byte, then you have PDU data, which could be 0 to 31 byte, which consists of 9 byte of prefix. This 9 byte of prefix contains AD type, manufacturer ID, company ID identifier. Proximity UID is a 16-bit identifier which distinguishes your device from any other device. Then 2 bytes for major number, which actually defines a group of the beacons, and 2 bytes for minor number, which can individually identify the beacon within a defined group. Then you have 2 bytes of transmitting power, which sends a 2 byte which are calibrated for 1 meter distance RSSI value. Then you have CRC of 3 byte. Step to generate BLE beacon using STM32WB. So these are the steps. We need to download and install STM32 CubeMx and also STM32 firmware library package for WB. Then we need to download and install ID, preferred ID. In this case, I will be using STM32WB Cube IDE. Update the BLE wireless stack of STM32W55 mounted on Nucleo board. If you don't know how to update the wireless stack, you can refer my previous video step by step updating the wireless stack of STM32WB. I have given the link in the description. You can follow it. Then we will create a project using STM32WB CubeMx. We will configure the peripheral and configure the BLE stack. Then we will generate the code in preferred ID. We will write some line of code, compile this code and load it into MCU. And we are ready with the beacon to check on our mobile phone. So let's start with CubeMx. So now we need to open STM32WBStep. Now we need to select our MCU using MCU selector. Just click on this. So in our Nucleo board, we have STM32WB55RG. This is the MCU that we have on our STM32WB Nucleo board. So we'll just select this MCU. So this is the interface where we have all pinout, peripheral and everything what we have in CubeMx. So I am not going to cover the details about the CubeMx in this video. So if you like, I can make a separate video covering all the features and benefits of using CubeMx and its library like HL and LL. So if you need those kind of videos, please let me know. I will make those videos for you. So, and please like and subscribe, and you also press the bell icon so you can get the notification on time. Now in this we need to select the sys peripheral, which is a system peripheral, to first configure the debugger pins. So here we configure the debugger pin. So here you can see these are the pins which assigned to the SWD protocol. Now we need to select the pin number PB5, so that we can select from here. We will just type PB5. So this is PB5. We will make it output. So actually, if you refer the schematic of Nucleo board, you can see there is a LED which is LED blue on this pin. So we will selecting this pin and we will just name it as LED_PLUE blue. Now we will select other peripherals, like we will select oscillator first. So if you go in RCC, here you have HSE, which is high speed clock, external clock, and then HSE and LSE. So here you can see both the pins are assigned. This is for HSE, these two pins, and this is for LSE. Then we also need to select another LED, which is green LED on PB0. So here we can make it an output, and we will give it username as LED_green. Now we also have a switch on Nucleo board which is actually connected on PC4. So PC4, we will select as a external interrupt. And we will give it name button_SW1. Now we'll go to GPIO section. And we will select the detection edge, which is external interrupt mode with falling edge detection for PC4. After this, we will go to UART1, and we will select into a asynchronous mode. So you can see the pin assigned here is PA10 and PA9, but as we have a converter, a USB to serial converter on STM32WB Nucleo board itself, which is available on PB6 and PB7. So we will just reassign these UART pin to the alternate pin on PB6 and PB7. UARTX and UARTRX. So you can see now this pin has been changed to the new one, the new location. Now we can just verify the UART configurations, which is this. Here we have 115200 baud rate, 8-bit data, parity none, stop bit 1, which is okay for us. Right? So we can keep them as it is. Then, so we need to select the hardware semaphore, which is HSEM. So we need to activate this hardware semaphore. This is very useful while both the cores, which is Cortex M4 and Cortex M0 Plus, they are interacting with each other. So these are semaphores which required if you are using both the core. So we will just activate this. There is no configuration needed for this particular peripheral. Then we need to come to the RF, which is here, and we need to select the RF1 pin. This will select a pin on the MCU. As you can see here, this pin is actually your antenna pin, the BLE antenna pin. Then we need to select RTC here, which is again required for Bluetooth functionality. This will be used while your Bluetooth is going into sleep mode and waking from there. So it is required to select. This will not assign any pin on the MCU. It is just an internal peripheral to use. Then we need to go to the Bluetooth part, which is STM32WBStep wireless pen, and here we need to select BLE, which is a BLE protocol. And within this BLE, you can see BLE application and services that we can enable as per our requirements. So you have different applications here, like on the server mode, you have your beacon, blood pressure, health monitor, heart rate, P2P server, custom template also you can build from there. So this BLE section we will see after doing other configuration. So now we need to go to the NVIC. Here it is. In NVIC we need to select the different interrupts that we are about to use. So we will be using external interrupt. So we will select this. Then we will use RTC wake up interrupt on line 19, and we will use UART interrupt. So we will select all these three interrupts. So for this application, there is no need to change priority. Now let's go to the clock configuration section. So it is showing like that your clock is not properly configured. So it's prompting you to solve the issue. So if you simply say yes, so it solved the issue, but you still need to do some changes here. So you need to first verify that you have an external oscillator which is there, and then from here you need to select here HSE system. So your clock to the system will be coming from high speed external crystal. Then you need to select LSC for your RTC domain. So your RTC will be running on external oscillator again. Now you need to also change the RF section clock. So you need to select here LSE here. So now our RF section, which is Bluetooth section in this case, will be running on LSE. So just cross check again that you have your both the code running at 32 megahertz for this case. You can change it if you want to other frequency as well, but you need to make sure that your RTC and your RF clock should be on LSE and your system clock should be coming from HSE. Okay, so far whatever we have done will remain common for other exercise also that we will do in the coming videos. So let's go back to pinout and configuration. Here we need to enable the beacon because we are doing beacon exercise, so we need to enable beacon. We keep the application type as server profile because beacon is used to be server which gives the information to client. So what is server, what is client, what is broadcaster, master, slave, that all we will discuss in separate video where I will cover Bluetooth specification, right? In the end, we have a local name, so we can change this name to our required name, which is I will give EM underscore talk, embedded talk. So this name is actually not useful for iBeacon example, but still I'm giving it because we can use it for next exercises. Let's go to project manager. In this, we need to give the name of the project. I'm giving the name beacon. You can give any location what you need. Then select ID as CubeID. So I am using CubeID right now. You can choose other also like IA or Kyle, whatever you want, right? And just uncheck this generate under root. Although this will not make much difference, this will actually make a separate folder for CubeID. Then hit code generator, keep the setting as it is, go to advanced setting. In this, you will keep everything as it is. The only point that you need to note here that your app init should be in the end. This should not be in between or in beginning because this will do the Bluetooth stack initialization and this should be after doing all the peripheral initialization. Once you done with all this setting, just go ahead and hit the generate code button. This will generate the code for CubeID and you can directly open the code from here only if you have the proper installation of CubeID and the CubeMx. Now you can open project from here directly. This will open project in CubeID. So you can keep the workspace path default and just click on launch. So here we go. We have this project now. Just click on this. Now you have your full application here. You can go to users. You have your main file here. Now go ahead and just compile the code to see if there is no error or it is successfully generated. So click on the hammer icon. So here there is 0 error and 1 warning. We can just ignore the warning. There is no issue with that. Now let's go back to the presentation to see the code architecture and the flow of the code, how it works. So if we see code flow of the STM32WB, so once we do the power on, it will reset, and it will first go to the reset handler, which is available in the startup file of Cortex M4, which is .s file. In this, it will do stack pointer initialization, it will do some variable initialization for SRAM, and it will also call system init function. After this will go to main, where this will do RCC clock initialization, RTC initialization, and other peripheral initialization, whatever you want to do. Then it will go to app entry.c file, where it execute app init function. In this will actually initialize the transport layer of Cortex M0 plus core. It will also do some other hardware configuration which is required for Bluetooth. Then it will go to app BLE.c, where this will actually do the BLE initialization. So it will call app underscore BLE underscore init function in this file, where this will do GAT and gap initialization. It will advertise mode control. It will set the transmit power, and it will also set it as a discoverable. So we will see all this function and all this code flow actually inside the code itself. But before that, let's first write some line of code to generate a iBeacon and to make the BLE work. For that, we need to first add an include file into main main file. Then we need to start the sequencer in the main file itself. So here one point I would like to highlight, as the BLE code architecture is quite complex and not possible to cover in one video. So I will cover it in a separate video, where I will cover sequencer, timer server, low power management. So that all I will cover in a separate video. Okay, now coming back to the code, then we will write some line of code in it.c file, where we will include one file, and then we have to write the IRQ for IPCC layer. So IPCC is actually a inter-processor communication controller, which required to communicate between these two cores. So I will again cover it in a separate video when I will talk about STM32WB features and hardware and everything. Okay, so let's go back to the code in CubeID, and then we will do some changes in that. Okay, so let's go to main file first. So in main file, as I mentioned, I can show you here. We will add this line. So this you can find in main file here. Just add this. Now we just copy this. Come back to this code that will copy just into main while one here. Then we need to copy this and need to go into it.c. and I can just add this line here. So all this command which I am showing, I will also give this command in description, so you can easily copy from there and paste into your code. Now just hit the compilation button. It should be 0 warning and 0 error. If there is some warning, then there is no problem in that, but there should be no error. Now you need to go into this icon, to click on this icon, and to click on debug configuration. After this, you just need to double click on this. This will create a new debug session. Here we go. So now we will dump this code into our evaluation board, Nucleo board. So just click on debug. This will load this code into the Nucleo board, and then we will run it. Now we are into debug session. So I am not going to explain too many things about CubeIDE. If you don't know how to use CubeIDE and its different feature, then let me know. I will make a separate video for STM32 CubeIDE as well. Now just go and hit the run button. After this, you need to open your mobile app, which you installed, which is ST BLE profiles, and you can just hit on scan and you can see the iBeacon visible on your mobile phone. So open the NRF Connect app, and then you can also change the RSI value here if you want to filter out some other devices which may be near. Then if you see, you can see this is iBeacon which we have just created, right? So in that way you can see the same the iBeacon in your mobile phone as well. Now we will have deep dive into the code. So just as exit from this debug session by clicking on this red button. So now we are out of the session. Now see whatever I have explained you in presentation, that how it is actually working. So as I mentioned, after entering the main, you will do the clock initialization. So here is the function using which you can see this is a clock initialization. Then you are doing GPR initialization, RF initialization, which is empty for time being because all this stuff will be done into the BLE stack. Then you have RTC initialization here, then UART initialization, and then finally you have a app initialization. So if you press F3, this will go to the function definition here. In this, you can see you have some timer server initialization here, which I will explain in a separate video. Then you have app transport layer initialization, as I mentioned before. So just again hit F3, you go inside this. Then you have transport layer initialization here. Then here you have IPCC initialization, you can see. So this IPCC initialization actually required so that your both core can communicate with each other over this IPCC layer using the mailboxes. Then go back, just click on, just press the Alt with the back arrow. You can navigate back to the previous screen. Now you are here. You can see it's registering some tasks into a sequencer. Then if you go into this app sys user event RX, if you go inside this, you can see it is actually enabling the CPU2. Then it is, after enabling the CPU2, it will do the BLE initialization here. go inside this. In this you can see you have get and gap initialization in this function. Here you are defining the MAC address or the BD address of the device. You are sending it over, ACI commands. So ACI commands is the application interface commands. So then you are here, you can see it is setting up the power level, and then finally you have a get initialization here. So in get initialization, let's go back. Then after this you have your ACI gap init, where you define the name of the device, but this name will be overwritten by the iBeacon characteristics that we will see soon. Then if you go back, then you have service initialization here. In this service initialization, you have this initialize requested services. If you go inside this, which is just below this, here you do all the services initialization that you want to do. Like if you want to use a heart rate profile, you have a heart rate initialization. Then you have different P2P server initialization, OTA initialization, like this. So all the initializations are available here that you can initialize from there, right? Then if you go back again, go one more time back, then below this you can see we are making this device discoverable with some beacon protocol. So you have Eddystone beacon available here, which is UID, Eddystone URL, Eddystone TLM, and then you also have iBeacon, which is from iPhone. So to use this, because by default this app is this CubeMx is generating code for iBeacon, so it is actually enabled right now. But you can change the setting if you want from this iBeacon config type. So you just click on this and then press F3. Here you can see. So if you change this beacon type to config iBeacon for, in place of config iBeacon, you can select Eddystone, any of them, and accordingly your beacon will be configured. So let's go back again by pressing Alt back arrow. So within this iBeacon, because this is enabled right now for our example code, let's go inside this. Here you can see they have defined some structure for the beacon characteristics. Then you have a beacon initialization, iBeacon initialization. In this, whatever I have shown you in the presentation, that you have some packet format, right? So that packet format is actually, you can see here, right? So they are calling AC gap set discoverable. So this is actually making the device discoverable. So when I say discoverable, that means any other device, like let's say mobile phone, it can scan it. So this will, your device, your nucleo board will broadcast the beacons and other device can discover it, right? So then it is adding the some values into this, as I shown in the presentation. It is giving the AD type, which is advertising non-connectable right now. Then it is giving you the advertising interval and advertising window. So this is actually for how many time it will how many duration it will advertise, and what is the delay between two advertisement. This is what it is more detail I will explain in my BLE video. Then you have public address, which is actually, this will be your MAC address, this will be. Then you have whitelist. Then you can give local name, but in iBeacon you don't have local name, so you will not give it. Then if you scroll down, you can see here we are giving the UUID, which is there, always there into a iBeacon. Then you are setting up some AD types, right, which is as per the table format table which I showed you before. So here if you see, what they are doing, they are just initializing an array. So whenever you update the advertising packet, you need to give the length first in the first byte. Then in second byte, you need to give the type of that packet. So that you can see this one or this one, it is specifying the manufacturer type, which is always FF. So if you just go into this, go to declaration, you can see it's FF. So whenever you are sending that command using that array, you need to select any one of them to define the AD type, right? So every time when it is defining this structure, it is giving the length of the packet, type of the AD type, and then the data, whatever you have. And at the end you have a minor number, major number, and the calibration RX power, which I shown you into the iBeacon format. So then once you loaded this structure with these values, you need to call the ACI gap update advertisement data function. This will actually update the advertisement data. Just for example, you can see here you are doing the UID, sending UID, and then again you are sending UID here. So even though and then you are sending this particular variable here, right? And this was on the upper variable here, right? So we are sending it 2 times. So this will actually change the position of the data, right? So even though if you don't send the second one, if you just comment it, still your iBeacon will be visible on your mobile phone, but the data position could be different because iBeacon is not identified by the data. It is identified by iBeacon prefix. So if iBeacon prefix is correct, it will identify the device as a iBeacon. So that's how we are updating the advertisement data for iBeacon. Similarly, you can do the changes or you can update the advertisement data for Eddystone beacon and or for other beacons. And you can also make your custom beacon if you want. Okay. So I think I have covered all the points. If I left something, please feel free to ask me. You can just give some comments. I will try to reply you. So thanks for watching my video. I hope you enjoy this. Please like the video and do not forget to subscribe to see more technical video of your interest. Thank you.